Okay. Question 5. So now we've moved on from using that table. We shouldn't have to too many more times. We're going to explore when you could use the normal approximation. So NP has to be greater than 5 and NPQ should be greater than 5. This criteria changes, by the way. Greater than 5 is what the New South Wales syllabus uses, but my uni courses use something different. But I cannot remember. So here NP has to be greater than 5. NPQ has to be greater than 5. So P equals 0.5. Q equals 0.5. So N has to be greater than times 0.5 has to be greater than 5. So N should be greater than 10. NPQ, so N times 0.5 times 0.5 has to be greater than 5. So N has to be greater than 20. So N has to be greater than 20. You just go with the most exhaustive response. Question C. So here P equals 0.125. So Q will be 0.875. So N times 0.125 has to be bigger than 5. So N has to be bigger than 5 divided by 0.125. 40. N times 0.125 times 0.875 also has to be bigger than 5. So N has to be bigger than 45.7. So let's say N has to be bigger than 46. And E, P equals 0.75. Then Q is 0.25. So N times 0.75 has to be bigger than 5. So N has to be bigger than 6.67. So N has to be bigger than 7. N times 0.75 times 0.25 has to be bigger than 5. So N has to be bigger than 26.67. So let's say N has to be bigger than 27. N has to be bigger than 27. That's it. Let's do question 6. According to some estimates, 8% of males in the world are colourblind. Oh, wow. A representative random sample has 854 people, and a statistician wishes to determine that probably between 7 and 9% of the people in this sample are colourblind. Explain why they might want to use a normal approximation. Well, let's see what 7% of 854 equals 60 people. 9% of 854 is 77 people. To calculate the probability that between 60 and 77 people are colourblind, you would have to do 854 C60 times, well, 0.08 to the 60 times 0.92 to the 854 take 60, 794 plus 854 C to the 61 times 0.08 to the 61 times 0.92 to the 60 plus, to the 793 plus, it's a huge calculation. So let's see if we can actually use it. NP is 854 times 8%. It's 68.32, which is well bigger than 5. NPQ is 68.32 times 0.92, 62.85, which is, again, bigger than 5. So the normal approximation is valid. Okay, question B. Comment on the assumption that the sample is representative and random. How on earth could you get a representative random sample of the whole world? Like, did they literally go to every single country and randomly choose people? How did they do it? Also, if you know that 8% of males are colourblind, then why are you getting females as well? So you can't really extrapolate that to females. Which again, make up half of the whole world.